Now you will see a trick. This is a trick. It's called logarithmic differentiation. And basically it uses the logarithm and the chain rule to find derivatives of difficult functions. So logarithmic differentiation works in the following way. We have a positive differentiable function u, and then we look at what happens if we take the logarithm, the natural logarithm of this u, and take the derivative. If we do that by the chain rule, first we should take the derivative of ln. That's just 1 divided by what we had inside. So it's just 1 divided by u of x times the derivative of what we have inside. So that's u prime of x. What is this good for? Well, here's an example. We have a function f of x equals x to the power x plus 1. X is positive, so this is this function here, right? And we want to find the derivative of this. Oh, no, it's this one. Right. But we don't have anything that allows us to differentiate this. I mean, we don't have any rules for something to this power sum. I mean, where the variable is base and exponent at the same time. We haven't seen anything like that. We know how to differentiate polynomials. This is definitely not a polynomial. It's a polynomial to the power some other polynomial. But we still want to find the derivative. So what do? We take the logarithm. Why do we do that? Well, one of the good thing about logarithms is that sometimes it simplifies things. So the good thing here is that if you take the logarithm of this function here, you pull down the exponent in front, right? That was one of the laws of the exponents. So now we have something that we can differentiate. Because if we take the derivative of this, I mean this combined thing, it's just using the product rule, right? Differentiate this, multiply by this, plus this times the derivative of this. So let's do that. So we knew from up here that if we had a positive function, clearly this is a positive function, right? Except at 0, but we exclude 0. Then if we take the logarithm and differentiate, we get something like this. So f prime of x over f of x is the same as the derivative of this, which is the same as the derivative of this. And then we just use the product rule, as I said. So the derivative of x plus 1 is 1 plus 0, right? Or just 1 times the logarithm. We keep that here. Then we say x plus 1, this is what we have here, times the derivative of the logarithm. That's just 1 over x. So if we just simplify things a bit, this 1 is irrelevant. We can exclude it. X times 1 over x is just 1, and 1 times 1 over x is just 1 over x. So this here has to be equal to f prime of x over f of x, right? So if that is the case, to get f prime of x, we just have to multiply by f of x. So f prime of x will be f of x times this, or simply this. So first of all, what did we do? We found the derivative of f. Then we found the derivative of, no, not the derivative, the logarithm of f. And then we took the derivative of that, which was this. And then we used this to get back to this. So this is a trick. It's something you can use if there are functions that are difficult to differentiate.